6A-1 prime factorization. So everybody should have at least 2 colors. Alright. Prime factorization. So what we're going to be doing today is, you've done in the past something like this probably. You've probably taken the number 12. Something like this. And you've probably broken it down by using a tree. What are 2 numbers that go into 12? 2 and 6. Can I break 2 down anymore?
No.
No. Can I break 6 down? Yes. 2 and 3. Okay, so you've done this before. But I'm not teaching you that way. Okay? We are going to be doing the exact same concept today. Okay, but I'm going to teach you something different. Alright, a different way of how to do it. And there's a reason behind that, because we're going to move on, and there's a reason I want you to do it my way. Okay? Because we're going to take it one step further. Alright, so you guys probably already know how to do this by doing the tree method, but I'm going to show you how I want you to do it. Alright, so we're going to review. First, we have to know what prime numbers are, composite numbers, and neither. So it says numbers that are only divisible by 1 in themselves. Well, what's divisible by 1 in themselves? What are those called? Those are called prime. Prime. You can only divide it by itself and the number 1. So everybody should write prime. Okay, just write in your regular pencil right now. Then on the other side it says numbers that are divisible by numbers other than 1 in themselves. That is composite. So, here, 12 is composite because you can divide it. Alright? 2 is prime because there's nothing, listen. 2 is prime because there's no numbers that can go into it except for 2 and 1. 6 is composite because it can be divided by 2 and 3. 2 is prime because it can only be divided by 2 and 1, Ethan. 3 is prime because it can only be divided by 3 and 1. Okay, does everybody understand composite and prime? If it can be divided like 12, got divided by 2 and 6, then it is composite. Okay, so take one color of your highlighters. Right? Now, we're going to start with the number 1. Number 1, is it prime, composite, or neither? What do you think number 1 is?
Prime. No.
Okay, so composite means that it can be divided by
1.
itself, or more than just 1 itself. So what can go into 1? 1. Is that more than itself? No. Okay, it can only be divided by 1. So that is going to be neither. Number 1 is the only number that is neither. So highlight that one color. That is the only number that will be neither. Okay? Okay, then we're going to move on to number 2. Number 2. I already told you that 1 is the only neither. Okay, so number 2 has to be prime or composite. Well, what goes into number 2? What can go into it? 1 and 2. Right? Because 1 times 2 is 2. So, prime is numbers that are only divisible by 1 in itself. Composite is more than that. Well, 2 can only be divided by 1 and 2. So, it is prime. Okay, so highlight prime a color, and then we're going to make 2 that color. Because this is review, and we need to move on, I'm just going to tell you which colors to make prime. Alright? So I'm going to go slow. So as I call a number out, I want you to make that your prime color. Okay? So 2 is prime. Everybody should have 2 highlighted. 3 is prime. 5 is prime. 7. 9. So everybody should be highlighting with me.
Wait, 9 is prime?
Uh-huh. Oh, no. Sorry. Not 9. Sorry. Don't highlight 9.
Oh, where did it?
Darn it.
I'm just going to put X.
Gosh darn it. Let me get a You guys out. It's not.
It's composite.
It is composite.
Yeah. I was like, oh.
I was going by 2. Okay. No. Put it out on yours. Whining it out because it's on. I'm really confused. Should be 9. That's my bad. Okay. Sorry. All right. Now, second row. Shh. All right, here we go. These are prime. Remember prime. So we're highlighting prime. 11, 13, 17, 19.
Are you sure this one?
Yes, I'm sure. 23, 29, 31, 37, 41, 43, and 47. 53, 59, 61, 67, 71, 73, and 79, 83, 89, and 97.
There you go.
That's what I said earlier. I feel like I'm playing bingo. Okay. So those are all your prime numbers. All right. Composite, we're going to leave white. Okay. So the prime kind of sticks out a little bit more. So just leave the composite white. If you really want to go back and make the composite a number, you can do that later. Okay.
Composite number?
You can color, sorry. Okay. Now, I told you guys that in the past you probably learned how to break down numbers by trees. So what I'm going to do is I am going to do it by the birthday cake method. And there's a reason that I want you to do it my way, okay? So anytime you're writing the prime factorization, listen, anytime we're doing prime factorization, we're going to do it by the birthday cake method, all right? Now, I want you to think of making a birthday cake. Or a wedding cake, because a wedding cake has the tiers. A birthday cake is usually just one cake. But a wedding cake usually has the tiers. When you're making the wedding cake, okay, just visualize it, you would start with the bottom tier, the biggest tier. And then you would take the next size and you would stack it on top. And then you would take the next size, a little bit smaller, and stack it on top, right? So when you start your cake, you start it where? At the bottom, right, with the biggest tier. So we're going to do the birthday cake method. And it says, always build your cake from the bottom up. Okay, because that makes the most sense. You don't start with the smallest one, and then you would have nowhere to stack it if you started with the smallest one. Okay, you got to start with your biggest tier, and that's on the bottom, right? Step 1, I've got the steps listed out for you. It says, the first tier will be the number you're finding the prime factorization of. So example 1 says, write the prime factorization of 42. But where do we start it? At the bottom, okay? So you're going to write 42, and you're going to have to write it kind of small at the very bottom of the box. Because this is going to be the bottom layer. Do you need a pencil or something? Do y'all have a pencil that you can borrow?
We're making it upside down.
No? Okay. Then it says, on the outside of the first tier, write the prime number that divides evenly into that tier. Okay. So I have a very specific way that I want you to do it. Do this. So how we're going to do it is we're going to start with 42 and we're going to divide it. But This is how I want you to do it every single time. So you're going to start with 42, and you go to your prime numbers at the top. And you start with the very first prime number. Well, what is the very first prime number? 2. 1 is neither. So 2 is the very first prime number. And I say, can 42 be divided by 2? Can it?
Yes.
Yeah, because it's even, right? It's even. So I'm going to put the 2 on the outside, just like a regular division problem. And then what is 42 divided by 2? 21. So that goes on top. All right, 21 is the next tier of the birthday cake. So now I'm going to draw the fraction bar, or the division bar. And then we go back to our prime numbers, and I start with the first prime number, and I say, can 21 be divided by 2?
No.
No, because it's not even. Then I move to the next prime number. Can 21 be divided by 3?
Yes.
Yes, okay. So, now 3 goes on the outside. What is 21 divided by 3? 7. Then I draw the division bar on 7. And I say, can 7 be divided by 2?
No.
No. Then I move to the next one. Can 7 be divided by 3?
No.
No. Can 7 be divided by 5? Can 7 be divided by 6?
Yes.
Yes. Okay. Put 7 on the side because it can be divided by 7. What is 7 divided by 7? 1. What do you think 1 is? There. It's the candle.
Oh, it's a candle?
It's the candle.
Oh.
So once you get 1 on top, once you get that candle on top, you're done. Okay? You're done. But does this look very mathematical?
Yeah.
No. This is just a trick
It takes
for
a
you.
little lopsided.
This is just a trick for you to get to the math terms, the math numbers that you need. Okay? The birthday cake is not mathematical. All right? People a long time ago did not come up with the birthday cake for Algebra 1. All right? That's something that we came up with. So, this is not your answer. Your answer are the numbers out here on the side. Okay? Those are your answers. And this is how we're going to write it. 42 equals 2 times 3 times 7 is your answer. Notice that I did not put an X for multiplication. Okay, I put the dot. We don't do X for multiply anymore. Okay? So the numbers out there on the side of the birthday cake, those are your answers. Questions?
What's concerns?
Okay.
Oh wait, yes.
What?
When we do the composite.
Composite?
Yeah,
We
composite.
will not do composite numbers will never go out here, only your prime numbers.
Okay.
So the only reason that we only highlighted prime numbers because those are the only numbers that we're looking at. Okay, those are the only numbers that we want, and so we highlighted them to stand out. Okay? Okay, example 2. Write the prime factorization of 120. So if I'm going to do the prime factorization, I'm actually going to do the birthday cake method. And where do we start?
The bottom.
The bottom. So I'm going to write 120 on the bottom. Now this one you're going to need to write a little bit smaller. The bigger the number, the smaller you need to write. Okay? All right, so do your first tier. Okay, then I go to the top and I say, start with my first prime number. Can 120 be divided by 2?
Yes.
Yes. Okay, so we're going to put a 2 out there. And what is 120 divided by 2? 60. So put 60 on top. And then we're going to make the next tier. And I go back to the prime numbers. Can 60 be divided by 2? Yes. So I put 2 on the outside. What is 60 divided by 2? 30. So the answer goes on top. Then I'd put my division. I go back to my prime numbers. Can 30 be divided by 2?
Yes.
Yes. So 2 goes on the outside. What is 30 divided by 2? 15. Put your division mark. Okay. Can 15 be divided by 2? No. Okay. So then I move to the very next prime number. Can 15 be divided by 3? Yes. So then I put a 3 on the outside. What is 15 divided by 3? 5. Okay, I'm on the 3s. Can 5 be divided by 3?
No.
No. So then I move to the very next prime number. Can 5 be divided by 5?
Yes.
Yes. So then I put a 5 out there. What is 5 divided by 5?
1.
1. And I have my candle. And when we get our candle, we are donezo. So these are my answers.
You don't eat the cake?
Not today. Those are my answers, and I have to
disappointed that you're like.
I have to write it in math terms. So 2 times 2 times 2 times 3 times 5.
That's beautiful.
I know, it really is. Ethan?
Would it be the same if we did it from like the top and the bottom, like the number?
That's okay. Make sure you have it. Okay. One more. Prime factorization of 40. All right, so where do we start? At the bottom. So I'm going to write 40 on the bottom. All right, start from the first prime number. So, can 40 be divided by 2?
Yes.
Yes, so I'm going to put 2 on the outside and the answer on top. What is 40 divided by 2?
20.
20. So that goes on top. Draw your fraction. We're still on 2. So can 20 be divided by 2? Yes. And what's the answer? 10. Can 10 be divided by 2? Yes. And the answer is?
5.
Can 5 be divided by 2?
No.
No. So then I move to the next prime number. Can it be divided by 3? Can it be divided by 5?
No.
So 5 divided by 5 is 1. And I have my candle, so I'm done. And I write my answer. 2 times 2 times 2 times 5. And remember, we don't put the X for multiply. We put the dots. Okay? Questions? This isn't a terrible way to come back, right? No.
It's pretty simple.
Perfect. Okay, so now you guys are going to do your practice, all right? There are some review questions on your practice that we learned last semester.
I already put my mind.
You guys act like last semester was like 3 months ago. It was 2 weeks. Okay. 2
But it
weeks
felt
ago.
like 3 months.
I know, it feels like 3 months. But you guys, I'm going to put a lot of review stuff on your homework. And it's really important that you either go back in your composition book and look at those problems because it doesn't just go away after Christmas. We still need to know how to do that stuff. Okay? So if you don't remember how to do it, you need to ask or look in your composition book, okay?